All right, today we're going to go on a pretty fascinating journey. Not across the world, but deep inside the machines we use every single day. We're going to break down the fundamental principles of computer science that power, well, everything. So let's just dive right in.
Have you ever actually stopped to think about that? You press one single key, and a letter just appears on the screen. But what really happens in that split second? Well, there's this whole invisible journey happening. And today, we're going to follow that command from start to finish.
So, first things first, what even is computer science? And it's way more than just coding. It's the study of the entire ecosystem, the physical hardware, the invisible software, the networks that connect everything, and all the data. Basically, it's the science that lets these machines think and work for us.
Okay, so let's get back to that keystroke. The second you press that key, you're sending a little piece of data on an adventure inside the machine. And this trip, it has 4 main stops, and we're going to check out every single one.
So here's the map of that journey. First, it starts with an input device, your keyboard. From there, the signal zips straight to the computer's brain, the CPU. Then the CPU uses memory to actually figure out what to do, and finally, bam, the result gets sent to an output device like your screen. Input, process, store, output. Remember that, because that's the fundamental loop of everything a computer does.
Now, the absolute hero of this whole operation is the CPU, the central processing unit. And look, calling it the brain isn't just a cute nickname. It's legit. It's this tiny little chip, but it's packed with billions, billions of microscopic on-off switches called transistors.
And if we peek inside this brain, we find 3 really important parts. First up, you've got the ALU. Think of it as the calculator part. It does all the math and logic. Then there's the CU, which is like a traffic cop, directing where all the information needs to go. And finally, you have registers. These are like the CPU's own personal sticky notes, ultra-fast temporary storage for whatever it's working on right this second.
Okay, so we've covered how the CPU thinks, but how does it remember anything? Well, that's where memory comes into play. And just like us, computers have their own special language for both thinking and remembering.
So computers really have 2 main kinds of memory. Think of primary memory, that's RAM, as your workbench. It's super fast, right there, ready to go. But the second you turn off the power, poof, the workbench is wiped clean. Then you've got secondary memory, like your hard drive. That's more like a library. It takes a little longer to find what you need, but everything is stored there safely for the long haul. Oh, and there's one more thing. Sitting right next to the CPU is this super fast memory called cache. It's for the stuff the CPU needs like all the time.
So, what's the actual language these machines speak? Well, it's called binary. Deep down at its core, a computer only gets 2 things, on or off. That's it. And we represent that with a 1 or a 0. So every single thing, every command, every photo, even that letter A you typed earlier, it all gets broken down into a long string of these 1s and 0s. That A is actually something like 01000001 to the computer. Okay, so far we've been talking all about the physical stuff, right? The body of the machine, the hardware. But what actually brings that body to life? What gives it instructions? Well, that's the software. You could almost call it the soul of the machine.
Now, the most critical piece of software has to be the operating system. You know them: Windows, Mac OS, Linux, even Android on your phone. Think of them as the master manager of the whole operation. They're constantly juggling resources, launching your apps, and basically acting as the middleman between the hardware, all the other software, and you. They make sure everyone plays nice.
So how does all this amazing software get made? Well, it's built using programming languages. These languages like Python, Java, C++, they're the toolkits that developers use to write out the step-by-step instructions that become the apps we use every day. They're pretty much the essential bridge between a human's idea and what a machine can actually do.
All right, let's pull back a bit. We've been focused on a single computer. Because let's be real, the true power today isn't in one isolated machine. It's in connecting billions of them together. So the big question is, how do they all talk to each other? Well, they do it through networks, and these networks come in all different sizes. You've got a local area network, a LAN, which might just connect the computers in your office or your home. Then you can scale up to a metropolitan area network, a MAN, which could cover an entire city. A wide area network, a WAN, can stretch across a country. And the internet? Well, that's the big one. It's the ultimate network of networks that connects pretty much the entire globe. Now, to manage all the information zipping across these networks, we rely on 2 key technologies. First, there are databases.
The best way to think about them is as massive, super organized digital filing cabinets. They make it easy to store and find data fast. And second, there's cloud computing. This is what lets us store our files and even run programs over the internet instead of just on our own computer. I mean, if you've ever used Google Drive or Dropbox, you've used the cloud.
Okay, so we've covered hardware, software, networking. That's a lot of the theory. But what does it all actually mean for you and me? Let's connect the dots and see how all this tech really shows up in our day-to-day lives.
And the truth is, it's everywhere. There's almost no part of modern life that isn't touched by computer science. Think about it. Online classes, mobile banking, streaming your favorite shows. Every single one of those things is powered by the exact same fundamental ideas we've just been walking through.
And maybe the most powerful, the most mind-blowing combination of all these principles right now is artificial intelligence. You know, AI. When you use something like ChatGPT, or talk to Alexa, or see a self-driving car, that's AI in action. It's giving machines this incredible ability to learn, to understand, and even to make decisions on their own.
But of course, with all this connection comes a really important responsibility: staying safe. Look, you don't have to be a tech wizard, but taking a few basic steps is absolutely crucial. Make sure you have antivirus software. Keep your firewall on. It's like a digital bodyguard for your network. Use strong, unique passwords, please. And of course, back up your important stuff regularly, just in case.
So there you have it. We've gone from a single simple keystroke all the way up to the complexity of artificial intelligence. It really is an incredible story when you think about it. And it kind of leaves us with this big, open question, right? What's the next big thing in technology? And maybe more importantly, what's your role going to be in it? Something to chew on. Thanks for coming along on this little journey with me.